Hello again, algebra students. We're going to spend one more day today working on solving literal equations. That's what we did in our last lesson. And in the last lesson, we just kind of had random equations with random variables. Today, we're going to be specifically isolating just one particular variable. We're going to be worried about the y today. Hopefully, you remember from last year when you graphed slope-intercept form, it's y equals mx plus b, sometimes you have to do some work to get the y by itself, and that's what we're focused on today. So I would suggest that you write these examples down, and let's take a look at how to solve this. So yesterday, or the last lesson, we were just picking any random variable. So again, today, everything's all about y. I want to get the y by itself. So to get rid of adding 3 to the y, I would want to subtract that 3. So I'll get that y equals, I'm just going to write it as x minus 3. Typically, we do want to have the variables before the numbers. For instance, if you wrote negative 3 plus x, it's not that it would be wrong. It's just that typically we want that x first. And again, thinking back to like slope-intercept form, y equals mx plus b, we would want that x to be before the subtracting 3 part. In number 2, right now the y is being multiplied by 6. To get rid of multiplying, I would divide. So the 6's will go away. And all I'm left with is that y equals x over 6. Sometimes they would also put a 1 in front of this, and then they could look at it and say, oh, I'm going to take the 1 and the 6 and make a fraction, 1/6 x. That's just another way to write it, but this for today is just fine. Once we're talking about graphing and getting slope-intercept form, the second option might be better at that point, but for now, the first one's just fine. In number 3, now I have to get rid of 2 things. I have the 5 that's attached to the y and the subtracting 10. Again, since the 5's attached to the y, I'm going to leave that alone. That's the last thing I'm going to get rid of. I would like to get rid of subtracting 10, so I would add 10 to both sides. And 10 does not match the 7x. It's not like terms. They don't turn into a 17x. What I'm going to have over there is just 7x plus 10. Then I would want to get rid of the 5. Now I'm going to divide, and we have a couple of options. Sometimes it's okay to just do one great big division, right? So I could make it look like this. I'm going to do this 2 different ways. And that's what my equation would look like. Y equals 7x plus 10 all over 5. That's fine. However, again, knowing why we're doing this, knowing that I'm going to want this to look like slope-intercept form, even if you don't really remember what that is, here's what I would prefer to do. Instead of dividing the whole side by 5, I would like to divide each thing individually by 5. Now I know that means this 7x over 5, that doesn't simplify. 7 doesn't divide nicely by 5. I would just kind of pull the numbers out in front and have 7x over, or 7 over 5x. But the 10 over 5, that does simplify. That's usually how we're going to want our answers to look. Number 4, I want to get the y by itself. I have to get rid of multiplying by x. So I would divide by x. This isn't looking at all like slope-intercept form. We don't have an x in the denominator. That's not our typical kind of an answer. But in this problem, since it's not specifically slope-intercept form, that's just fine. In number 5, I would want to get rid of the dividing by 4 part. Remember, I'm trying to get the y by itself, so I would multiply by 4. Remember, multiplying goes on the sides, not underneath. And I'm going to get that y equals, I wouldn't usually write x4 either, I would write 4x. Number 6, the fact that the y is on the right-hand side doesn't matter. I still want the y to be by itself. So to get rid of multiplying by the 3, I would divide by 3. And I know that the 8 doesn't divide nicely by 3, and that's okay. you can either leave it as one big fraction, 8x over 3, or 8 over 3 times x would be just fine as well. And I truly don't care if you flip-flop and put the y first. You can, but you really don't need to. In number 7, again, remember, I'm trying to get the y all by itself. I need to be careful on this one. I would do a keep, change to make sure that I can see that that's really a -3 that's with the y. And then I would want to get rid of the 12. Because again, the -3 is attached to the y. That's the last thing that's going to go away. So I have to get rid of adding 12, so I would subtract 12, both sides. So I'll have 9x minus 12 equals -3y. Now this is actually nicer than one of the earlier problems that I did because I'm going to end up dividing by -3. The nice part about this is that the 9 and the 12 can both nicely be divided by 3 or by -3. So I'm going to do this division as two separate divisions on this side. Everything's still getting divided by -3. I'm just writing it separately. And I would also do a keep, change right there. So 9x divided by -3 is going to be -3x. -12 divided by -3 is +4. And on the right side, all I have left is y. So again, I am perfectly fine with this answer. If you want to make the y first, that would be just fine as well. And the last problem. Now, there is more than one way to do this. Some people would, instead of doing what I'm going to do, I'm going to distribute the 3 because that's what I'm guessing most people would want to do. Some people would just divide both sides by 3, which works. And if you're careful with that, you can do that way. But I'm going to do this because typically I would expect students to do this. So that's going to be 15y plus 12 when I distribute equals 6x. And again, remember, I'm trying to get the y alone. So I have to get rid of the 12. I'm going to subtract 12 from both sides, and it doesn't match with that x term, so it's just going to be 15y equals 6x minus 12, or plus a -12 if you'd like. And then I have to divide by 15. Now, 6 and 12 don't divide by 15 as whole numbers. However, if I look at those as fractions, I can do some simplifying. So I'm going to choose to keep them separate and simplify that as I go. So I'm going to get that y equals 6 over 15. If I would divide both of those by 3, this would be a 2, and this will be a 5. So I would have 2/5 x, or 2x over 5, plus a negative, or I guess I could have just left that as a subtraction. Divide by 3 again. This time I'm going to get a 4 here and a 5 here. That answer, it looks kind of messy. I realize that because of the two fractions. If you had just done one great big division by 15, your answer would look like this. You'd have the y by itself. You'd have the 6x minus 12 all over 15. The problem is that that's still not exactly reduced or simplified as much as you could, like we did with our individual fractions. So this isn't really done all the way, but that's another way to look at this problem. Now, today's practice problems are on a worksheet. It says review literal equations worksheet. Make sure that you are showing all of your work. These problems are not that difficult. It's just using all of your equation solving skills. It's just that now we're just moving stuff instead of actually crunching numbers. When you're done, make sure that you check your answers with the answer key. And then when you're done with that, we have that daily formative assessment. Make sure that you take that and let me know if you need any help.